Have you ever wondered if you could leap through time, visit the past or future? Today, we're going to explore the enigma that is time travel, an idea that has captivated the minds of many and has been a staple of science fiction for over a century. From the fantastical journeys of H.G. Wells' The Time Machine to the mind-bending adventures in the Back to the Future trilogy, time travel has been a subject filled with wonder, mystery, and endless possibilities. It's an idea that appeals to our curiosity, our desire for adventure, and our longing to change the past or foresee the future. But time travel is not just a staple of fiction. It's also a topic that has stirred up profound philosophical debates and scientific inquiries. The concept of time itself is a complex and puzzling one. Is it linear or cyclical? Is it a dimension in itself or merely a construct of our perception? And then, of course, there are the paradoxes. The grandfather paradox, for instance, poses the question: if you travelled back in time and accidentally prevented your grandparents from meeting, would you cease to exist? These paradoxes might seem like mere thought experiments, but they raise serious questions about the nature of time and the consequences of meddling with it. Beyond the paradoxes, there's also the question of causality, the principle that cause precedes effect. If time travel were possible, could actions in the future affect the past, thereby violating this fundamental principle? And let's not forget about the laws of physics. While some theories suggest that time travel could be possible under certain conditions, others argue that it would require energy levels or speeds that are simply unattainable. So while time travel is a fascinating concept and a beloved plot device in many stories, it's also a deeply complex and controversial topic in the realms of philosophy and science. As we delve deeper into the subject, we'll come to understand why many scientists believe that time travel, as much as we might wish for it, might remain a fantasy. While it's a tantalizing idea, let's delve into why scientists believe time travel might remain a fantasy. Albert Einstein, one of the most brilliant minds in history, had a significant say on the topic. Einstein's theory of relativity is a cornerstone in our understanding of the universe. This groundbreaking concept, presented in two parts, special and general relativity, has reshaped our perception of space and time. Special relativity, introduced in 1905, tells us that the laws of physics are the same for all non-accelerating observers. It also states that the speed of light, approximately 186,000 miles per second, is constant and independent of the motion of the light source. This means that, theoretically, if you could travel at light speed, time would appear to slow down for you compared to someone stationary. However, the catch is that according to Einstein's theory, as an object approaches the speed of light, its energy increases, and so does its mass. This leads to a conundrum. The closer you get to the speed of light, the more energy you need to keep accelerating, but your mass also increases, making you harder to accelerate. Eventually, you'd need an infinite amount of energy to reach light speed, which is clearly impossible with our current understanding and technology. General relativity, presented a decade later, expands on this by incorporating gravity into the mix. It describes gravity not as a force, as Sir Isaac Newton did, but as a curvature of space-time caused by mass and energy. Time, under the influence of gravity, can also dilate or slow down. This has been experimentally confirmed with precise clocks on airplanes and satellites showing slight discrepancies. However, while Einstein's theories allow for time dilation, they do not permit actual time travel as we often envision it in science fiction. There's no turning back the clock or fast-forwarding to the future. Time, as far as we know, marches forward and we're all along for the ride. So according to Einstein, time travel as we imagine it remains out of reach. Let's not forget the strange and fascinating world of quantum mechanics. It's a realm where particles can be in two places at once, where time doesn't always march forward, and where reality itself seems to be a fuzzy concept. In this quantum realm, time is not necessarily a one-way street. Rather than a single, linear timeline that we're accustomed to in our everyday lives, quantum mechanics suggests that time might be viewed as a vast landscape of possibilities. This is where we encounter the concept of quantum superposition, the idea that particles can exist in multiple states at once until observed. Imagine a particle that can take two paths. In the classical world, it would have to choose one or the other. But in the quantum world, it can take both paths simultaneously, thereby creating a superposition of states. Now, if we apply this to time, it suggests that multiple timelines could exist side by side in a state of quantum superposition. So, does this mean time travel is possible? Well, theoretically, yes, but there's a big catch. Quantum superposition happens on the scale of tiny particles. It's not something we can apply to macroscopic objects like a time machine or a human being. Furthermore, the quantum view of time is probabilistic. It's based on the idea that the future isn't set in stone, but rather a collection of possible outcomes. This clashes with the idea of time travel, where one would move along a definite, predetermined timeline. In addition, quantum mechanics introduces the concept of quantum entanglement, where particles become intertwined in such a way that the state of one instantaneously affects the state of the other, regardless of the distance between them. This further muddles the picture as it introduces non-locality, which defies our everyday understanding of time and space. Quantum mechanics, then, presents another roadblock to our time-traveling dreams. It suggests that while time travel might be theoretically possible on the quantum scale, it's likely out of reach for us humans, at least with our current understanding of the universe. The concept of time travel also brings with it a host of paradoxes. Foremost amongst these is the well-known grandfather paradox. Picture this. A time traveler journeys back to an era before his grandparents met. In a twist of fate, he inadvertently causes the death of his young grandfather, long before the birth of his father or mother. This would mean that the time traveler himself could never have existed. But if he never existed, how could he have travelled back in time to cause his grandfather's premature demise? This paradox creates a loop that's impossible to reconcile with our understanding of cause and effect. Then there's the bootstrap paradox, a concept that blurs the line between the chicken and the egg. Imagine a time traveller who adores Beethoven's music. He goes back in time hoping to meet the great composer, only to find out that Beethoven never existed. So he decides to publish all of Beethoven's works himself, ensuring that the world still gets to hear the beautiful symphonies. But here's the catch. If Beethoven never actually existed, where did the music originally come from? The bootstrap paradox suggests that objects or information can exist without having been created. These paradoxes present a conundrum. They challenge the very logic of time travel, creating inconsistencies that science can't currently resolve. Is it possible for an action in the past to influence the future, even if that future action was the cause of the past event? Could information or objects truly exist in a loop without a clear point of origin? These paradoxes force us to question our understanding of time and causality. They introduce complexities that make the concept of time travel seem more like a science fiction trope than a potential scientific reality. While we may dream of hopping into a time machine to explore the past or future, these paradoxes underscore the challenges and contradictions inherent in such a journey. These paradoxes further complicate the idea of time travel, making it seem even more unlikely. So, where does all this leave us in our quest for time travel? After a deep dive into the mysteries and complexities of time, we've journeyed through Einstein's theory of relativity, explored the perplexing world of quantum mechanics, and wrestled with the baffling problem of paradoxes. Each of these elements has given us fascinating insights into the nature of time and our relationship with it. Einstein's theory of relativity, with its groundbreaking concept of space-time, has shown us that time is not an absolute, but rather a relative concept, intertwined with space and affected by gravity and speed. Yet, while this theory allows for the possibility of time dilation and even wormholes, it doesn't provide a practical or feasible method for time travel. Quantum mechanics, on the other hand, has opened up a world where particles can exist in multiple states simultaneously, and where cause doesn't necessarily precede effect. It's a realm where the concept of time as we know it seems to lose its meaning. But again, the quantum world is far removed from our everyday reality, and its implications for time travel are more theoretical than practical. And then there's the problem of paradoxes. The classic grandfather paradox, where a time traveler could potentially prevent their own existence, presents logical inconsistencies that seem to defy the very possibility of time travel. So what's the final verdict? Time travel, at least as we've come to imagine it through science fiction, is currently beyond our scientific understanding and technological capabilities. It's a captivating concept, that has captured our collective imagination, inspired countless stories, and driven scientific inquiry. But for now, it remains just that, a concept, a theoretical possibility that exists more in the realm of speculation than reality. As we continue to explore the mysteries of the universe, who knows what we might discover? But for the time being, we must accept our place in the flow of time, moving ever forward, unable to turn back or leap ahead. Time travel, as captivating as it is, remains for now in the realm of fiction, a testament to the power of human imagination.